All right, so let's get on with another lesson. This is actually a lot different than the last two lessons that we did. We did all that ortho center, in center, and all that kind of stuff. All right, so it's quite a bit different, but it's kind of easy. Let's take a look at the first thing right there, inequalities. What does that mean to you? Not equal. Very good. I like that. So what we're going to do is we're going to do a comparison. So if I compared two things that were actually equal to each other, let's say 5 and 5, what symbol would I put inside there? This is not a trick question. It's that easy. What symbol? An equal sign, right? Okay. What if I did this? And so I'm comparing, right? I'm comparing this number to this number. If they're exactly the same, we say they're equal. What if I did this? These are the same numbers I did in the last class. What if I did a 5 and a 7? Then what is 5 compared to 7? It's lower. Okay, give me something a math thing that we usually say, less than. Very good. Okay, so 5 is less than 7. Okay. Somebody in the last class, use a shark or alligator. I think a lot of teachers, I don't know where that came from. I never learned that when I was a kid. No teacher ever did that. The alligator thing, where it eats the bigger numbers, something like that. Okay, here, I'll show you really where it came from, okay, instead of doing a little elementary school thing to remember which one's greater, which one's less. So an equal sign, I'm going to do it a little bit bigger equal sign. Okay, so that's an equal sign. Would you agree? All right, so look at the space between here and here and here and here. It's the same, isn't it? Okay, see it? It's basically two parallel lines, right? Would you agree? Kind of dissecting what an equal sign is. But what if I did this? What if I took this side, it made it closer to this side? So what about the space in between them now? It's literally an alligator? I don't think it's literally. If it's literally, if you use the word literally, it would be an actual alligator right on my screen. It's not a literal alligator. But look what I just did. I took those equal signs. Now, look at the distance between the end here and the end here. It's what? Compared to this distance. It's less than, right? So that's right. That's what this is. Shh, just listen to me. I'm trying to explain it, and you keep on talking. All right? When you're in elementary school or middle school, they always do the alligator thing. We're in high school now, okay? We're older. We don't have to worry. We don't have to think about little alligators and having big mouths and eating the bigger number and all that kind of stuff. Because I'm showing you where this symbol actually comes from. If you want to think about it being an alligator, eating the bigger number, that's fine. I don't care. I'm just showing you where this comes from, right? So an equal sign, they're the same distance between those two line segments, correct? What did I do? I put those closer to each other. So what is the distance between these points? It's a lot less than what? The distance between here and here. So this symbol would be considered what? Less than. So watch. That's less than. Okay? Everybody see it? All right? Because look, see that point? That's a shorter distance between these 2 points. So that's less than. Now, I could also... That's looking at it from left to right. What if I looked at it from right to left? What would I say? I would say 7 is greater than, you see it? So if I read from right to left, this would say 7 is greater than 5. So I could say it both ways, couldn't I? I could say 5 is less than 7, or I could say it 7 is what? Greater than 5. Everybody see that? All right. It's important to know your inequality symbols, your less than, your greater than, and that kind of thing. So what if I asked you to compare two numbers, like A and B? Now, you don't know what A is and you don't know what B is, but you got 3 choices, don't you? Excuse me. A could be what? Equal to B, right? So A could be equal to B. A could be what? Less than B, or A could be greater than B. Are there any other choices? No. So we give this a big fancy name. You don't have to worry about this. It's not going to be on a quiz or a test or anything like that. I'm trying to give you some stuff here. Terrell, you working on that quiz? All right, just because I'm talking, I know that's automatically means you go to sleep, but you got a quiz in front of you. You should be working on it. So we call this, here's a big fancy word, tri. Why do you think I use the prefix tri? Because there's 3 of them, right? We call it a trichotomy. It's a big fancy word. that people actually use it in real life, not just talking about geometry, not just talking about equal, less than, greater than, but they talk about if you have three choices, all right? If you have three distinct choices, they would say, oh, you've got a trichotomy. If you have two choices, they would call it a dichotomy, all right? You'd think they would say bi because bi meaning two, but di also is a prefix that sometimes means two as well. But anyway, that's a word that you might hear in maybe not your normal everyday life, but when you become older and you listen to the news or you listen to people talking real fancy, you might hear that word, trichotomy, all right? So that's what it means. What's that? I have heard it, yes. Because every time I hear it, I don't hear it often, but every once in a while I hear it, I'm thinking, oh yeah, I teach that in my math class, right? And I tell the kids to listen for that word. So you probably never heard it because you never heard it before. You were never probably, you might have heard somebody say that word, but it just never occurred to you. You know what I mean? But now, hopefully, it'll occur to you if you ever hear anybody say it. It's not that big of a deal. I spent way too much time on that. All right, so let's do this. We have a thing called the comparison property. So that's what we're talking about. We're talking about comparison, right? Comparisons. Compare one number to another number. So one number could be equal, could be less, could be greater. That's what we're doing. We're comparing them. So they actually came up with this thing called the comparison property. It's kind of common sense, to tell you the truth, but they put it in writing. They made it official, okay, if you want to call it that. So here's what the comparison property says. It says if A equals B plus C. Now, they give you a little bit of guidance on C. In order for this to work, C has to be greater than 0, so C has to be positive. All right, as long as C is positive, then this thing works, okay? So that's all this is right there. You can almost put it in parentheses. All right, so if A equals B plus C, right, then, watch this, A must be greater than B. All right, well, let's think about this for a second. Thank you. Let's put some actual numbers in for A, B, and C. All right, so give me three numbers that these two numbers add up to A. So give me a number that two numbers add up to B. What's that? Which is, okay, so 4 is your A then, right? Do you agree? You said 1 plus 3, right? So 4 equals what? 1 plus 3. Everybody agree with that? I put your name on it. Name was already on it. All right, so let's see if this works. What does this say? It says if A equals B plus C. Does this equal this plus this? Yeah, it does. Then what must be true? A, which is what? 4, must be what? Greater than what? B, which is 1. Would you agree that 4 is bigger than 1? Yeah, absolutely. Because if 1 plus 3 equals 4, if these two things add up to be something, then that something that it adds up to be has got to be bigger than the two things that are adding up to it. Make sense? All right, so let's use these markers. Do I have another color? That's okay. I'll use the same colors, don't I? So watch. If I have this and I have this, and they add up to be this, okay, the whole thing, then this whole thing has got to be bigger than the two things that add up to that it becomes. Does that make sense? Didn't word that very well, but this thing right here, how did I get this? I took this and I added it to this. Agree? So that must mean that the whole thing has got to be bigger than the parts that make it up. Do you hear me? Okay, the whole thing has got to be bigger than the parts that make it up. So let's do a little bit more with this. Now I said then A has got to be greater than B. You could also say what? A also has to be bigger than what else? C. Very good. Because and so you could put an and. You could say 4 has got to be greater than what else? 3. So that makes sense, doesn't it? Now, this is just numbers, okay? This is just arithmetic. The same thing applies when you're dealing with geometry, okay? Lengths of sides, angles, all that kind of stuff. So now let's draw a situation where we take what we just learned and we expand it to some geometry. Okay, we'll call this one an angle 1. I'll call that point A, call that B, and call that C. All right, let's think about this. I'm going to think about it first, and then we're going to give the name of the theorem, and we'll say what the theorem says, okay? But again, it's almost common sense, all right? We've actually talked about this before. Do you remember this? When you have an angle and you extend one of the sides, what do we call this angle right here? I mean, it's obtuse, that's true, but it's on the outside of the triangle. So what angle do we call this? The what? Exterior angle, very good. So I'll shorten it. Okay, so that's the exterior angle. Do you remember what we talked about compared to angle B and C? The exterior angle is equal to the sum, remember this, of the, what did we call these angles right here? Anybody thinking? Looks like I see a few of you thinking, not everybody. What do we call this? The exterior angle is equal to the sum of the, okay, they are interior angles, but there's one word before it. Remember, it's kind of far away. B and C are far away from 1. So what do you do when you're watching TV? Right, the remote interior angles, right? Remember that? Gave a big story about the remote control when I was a kid. I had to walk up and click the channel on the TV. Remember that? So it's the sum of the remote, what? Interior angles. You remember that, don't you? That's old. Okay, we've talked about that before. So let's see how that has anything to do with what we've been talking about with the inequality stuff. So that means that angle 1 has got to equal what? The sum of the remote interior angles. Which ones are my remote interior angles? Angles what and what? No, A is not a remote interior angle. B and C. That's right, B and C. So I could say that angle 1 is equal to what? Angle B plus, right, because it says the sum, angle B plus what? Angle C. Would you agree with that statement right there? Yeah, that's old. Okay, that's not even new. It's not even what we're doing today, but it's going to lead us somewhere. Do you remember what that comparison property thing said? It said if what? If A was equal to B plus C, all right? Yeah. You're supposed to be taking it. Okay. You got to finish quiz first. No, you got to finish quiz. Okay, everybody look here. So what did that comparison property say? It says if A is equal to B plus C, then A's got to be bigger than what? B, and A's got to be bigger than C. So in this situation, what can we say? Angle 1, this angle right here, has to be what? Bigger than angle B. And angle 1 has to be bigger than angle C. Good. Everybody with me on that? So if I asked you to compare angle 1 to angle B, what would you say? You would say angle 1 is greater than angle B. What if I told you to compare angle 1 to angle C? What would you say? Angle 1 is what? Greater than angle C. What if I did this? What if I said angle 1, I put a blank, I'm sorry, let's do it the other way. What if I said angle C, I put a blank, and I put angle 1, and I asked you to compare those two angles, angle C to angle 1. What is angle C compared to angle 1? Angle C? Angle C would be less than 1. Angle 1 would be what? Greater than C. But if I put C first, angle C, that's got to be less than angle 1. So what do I put here? Less than. Okay? You with me on that? Or I could say angle 1 blank angle B. So look at angle 1, compare that to angle B. What is angle 1 compared to angle B? It's greater than. So that's what you would put. Does that make sense? All right. So if I ask you to compare them, that's what it's asking you to do. Tell me if they're equal. Tell me if it's less than. Tell me if it's greater than. You got those three options. You with me so far? All right. So they give this a name. I don't even care. It's called the exterior angle inequality theorem. I wrote that down in the last class. I'm not even going to write it down here. But that's what it says. The exterior angle is bigger than either one of these remote interior angles. That's what it says. And it makes sense, doesn't it, from that comparison property. See how we're all building? All right, here's another one. This one, this is really useful. I remember specifically this being on quizzes and tests, okay? So this is really important. I'll even give you the name of it. It's called the greater angle theorem. And this is really important because you're going to be doing several problems on a quiz and a test where you have to do this. So I am going to just draw some kind of triangle. Draw that to there, draw that to there. It's good enough. All right, and I'm going to give you the lengths of the sides of the triangle. I'm going to say the length of that is 13, that one's 12, this one's 14. I'm going to put some letters in here. This is L, this is M, and this is N. So here's what I'm going to ask you to do. And well, we first got to talk about the greater angle theorem first. Here's what it says. I'm going to read it to you. I'm not going to write it down, but we're going to see on this picture how it works. But I'm going to read it to you. It says if two sides of a triangle are not congruent. Okay, so that means at least two of the sides are not equal to each other. Do we have that situation here? Do we have two sides that are not equal to each other? Yeah, none of the sides are equal to each other, are they? Okay, so yeah, so we got that situation. So if we have that situation, it says the larger angle is opposite the larger side. You hear what I just said? Are you concentrating? The largest angle is opposite the largest side. So let's take a look. This may not be drawn perfectly to scale, but that's okay. All right, let's just use our theorem. So which one, so what I'm going to ask you to do is I'm going to ask you to put the angles in order from the largest to the smallest. All right, so I'm going to give you 3 blanks. Okay, so what's going to be in the biggest blank? The what? The largest angle. Which one's going to be in the last one? The smallest one. And the middle one's going to be in the middle. Okay, so how do I know which one's the largest angle? They don't even give me any numbers for the angles. How do I know? Do I just look and say, oh, that looks bigger than that? Is that what I do? No, I look for the lengths of the sides. Okay, so what's the biggest side? 14. So what's the angle that's opposite the biggest side? Angle M, that's right. Do you see it? See how it's opposite? So angle M is opposite the biggest side, so angle M is the what? The biggest angle. So where do I put that? Put it first, that's right. So put this angle symbol, okay? I kind of got on the last class a little bit, so I'll get on you a little bit. When I ask for a line segment, okay, or a side of a triangle, you need to put the line segment symbol, okay? If I ask for a triangle, right, and it's triangle ABC, what should you put in front of it? A triangle. What if I ask for an angle? Okay, you put the angle. It's not an L, it's an angle symbol. Okay, so whatever the angle is, angle A or whatever, okay? Everybody with me? So I'm asking for angles. So what do I put in front of it? An angle. That's not an L, that's an angle symbol, okay? Yes. All right, so that's the largest angle. Let's go to the smallest one. What do you think the smallest angle is going to be? Angle L. How do you know that? It's opposite the smallest side. Right, 12 is the smallest side. Angle L has got to be, now again, my angles and my L's kind of look the same sometimes if I'm kind of sloppy. All right, and of course, which one's the middle one going to be? Angle N, right, so angle N. That's the kind of question I could put on a quiz or a test, okay? Something just like that. I'll say, I don't know exactly how I word it, but it'll be something like put them in order, right? Put the angles in order from the largest to the smallest, okay? Or I could ask it another way. How else could I ask it? From the smallest to the largest. And that would be easy. Put 3 blanks here. Okay, which one's the smallest one? Angle L. Which one's the biggest one? Angle M. And of course, the middle one's going to be the middle one on both of them, right? So make sure you read it. Make sure you read, does it say from the largest to the smallest or from the smallest to the largest? Right? Some people just automatically go large to small, or some people automatically go from small to large, but you got to read the instructions, right? And they'll tell you which order to put it in. It's pretty easy, isn't it? Yeah, that's all you got to do. Okay, no math involved, really. You just got to see which one is the biggest one. Okay, that's the biggest one, so that's the biggest one. This right here is the smallest one, so this is the smallest one. And of course, the other two would be the one in the middle. Simple. Okay? All right. So let's do another one that's very similar to that. That's called the greater angle theorem. This next one is called the longer side theorem. Let's just write that down. It goes along exactly like the other one did, the longer side theorem. All right, let's draw another triangle. It's really not that different than what we were drawing before. It may not be to scale, but that's good enough. So let's say that's 100 degrees. Let's say this is 60 degrees, and let's say this is 20 degrees. And this is A, this is B, this is C. Oh my word, what in the world's going on next door? I just...
Bang on the wall back.
No, I will not do that. So, what do you think they're going to ask here? They told you the angles. So what do you think they're going to ask for? The largest side and the smallest side and the middle side, right? So this time, see, this is the longer side theorem. So it goes along just like the other one did, okay, the greater angle theorem. So let's go from, what do you want to go from? Let's go small to large this time, okay? So from small to large. Now this time, we're finding the what? The sides, right, that are the smallest to the largest. So I'm not going to put an angle in there. I'm going to put the sides. How do I show a side, by the way? With a little line over top of it, right? Okay? All right, so which one is the smallest side? Like Mr. Hammer, they didn't even tell us any lengths of the small, of which one's bigger, which one's smaller. Okay? I could guess, but is that a good way to do it? No, because they don't always draw the picture to scale, all right? So I could guess, but that's not a good way to do it. So how do you think I find the smallest side? I look for the what? The smallest angle. Which one's the smallest angle? C, angle is 20 degrees. So which side is opposite the smallest angle? This side right here, AB. So AB is the what? It's the smallest side. Okay, what about the biggest side? The largest side. Where are you going? Okay. What about the largest side? So where do you look? You look at the angles, right? 100 is the biggest angle, isn't it? So what side is opposite that 100? This AC right here. So AC would go last because that's the largest side. Which one would go in the middle? Yeah, BC. Notice I asked for a line, I asked for the side, all right? Sides are line segments, so you put the line segment symbol over top of it. Super easy, isn't it? Yeah, really easy. Okay, again, I could ask the question how? From what to what? I could go from large to small, right? So let's do that. So I'm going to put 3 dashes down. All right, so what's the largest side? AC. It's a side, it's a line segment, put a line segment symbol over top of it. I always like to do the large one and the small one, put the middle one last, okay? What's the smallest one? AB. And the middle one is BC. And there you go. No big deal. Would you agree that's super easy? Yeah, absolutely. All right, got a couple more things, and then we'll be done. Let's talk about a right triangle now. We've talked about right triangles before, and we might have talked about what I'm going to mention, but I don't think I really gave a reason necessarily. So there's a right triangle. Let's just call it ABC. If that's all I told you, okay, I didn't tell you any other angles, I didn't tell you any other sides, you should be able to tell me what the longest side of this triangle is. Not just because it looks like it, but you should be able to give me a reason. Opposite the right angle. Why? Because the right angle is always the what? The biggest angle in that right triangle, isn't it? Okay? Because remember, these two are acute, which means less than 90. So this is always the biggest angle. So look at this side right here. This side is opposite the biggest angle. So what side is the biggest side? AC. We'll put the largest side. So the largest side would be what? AC. Put the line segment over top of it. That's the largest side. Why? Because it's opposite the what? Largest angle. All right? The thing that we just finished talking about applies to this as well. So if I ask you for the largest side, you should be able to tell me it's line segment AC. Mario, you said it earlier. We give it a special name. That longest side of a right triangle, the side that's opposite the right angle, has a special name. What is it? It's the hypotenuse. We've talked about hypotenuse in here, haven't we? Seems like it. The other class stared at me like I had 3 heads or something. Like, what are you talking about? And I'm almost positive we talked about hypotenuse. But anyway, that's what the word is, okay? It's hypotenuse. And what do we know about the hypotenuse? It's always opposite the what? The right angle. So this theorem says that the hypotenuse is always the longest side of a right triangle, all right? So the hypotenuse is always the longest side of a right triangle. That's what the theorem says. Pretty simple. One more thing, and we're done. This is super easy. So what if I give you a line? It could be a line segment as well. Straight there, good. And let's say I put a point. Let's put it right there. And I asked you, what if I asked you to give me the shortest distance from this point to this line? Would you go to there? Is that the shortest distance? I mean, that's that's shorter than over here, isn't it? Okay, but what's the absolute shortest distance from this point to this line right here? Okay, straight down. Yeah, Mario said it. Okay, and I did hear you say it the first time. I was just wanting to talk about it a little bit. All right, so it's perpendicular. Okay, so the shortest distance, and we've actually talked about this before. Remember we did altitude? Okay, altitude from a vertex perpendicular to the opposite side. That was also the shortest distance. Okay, same thing here. All right, from a point to any line. The line could keep going forever, or it could be a line segment like this one is. All right, the shortest distance is the perpendicular distance. All right, I could have a line like this. Okay, and a point out here somewhere. And if I asked you to draw the shortest distance from that point to this line, how would you draw it? You wouldn't say straight down, would you? Okay, that's why I didn't like you saying straight down on the other one. All right, this is not straight down, but what's the distance? Is it to there? Is it to there? Is it anywhere in between? It's perpendicular, right? So I kind of have to eyeball it a little bit. And that, if that's perpendicular, then that's the shortest distance from this point to that line. So everything we've been talking about today are inequalities, right? Comparing. Is it longer? Is it shorter? Or it could be equal, right? But most of the stuff we did today, stuff was greater than, less than, and that's kind of what this is. This is the shortest distance. This is the least distance that you would have to travel to get from one point to that line right there. Make sense? Yeah, I think that was pretty easy. It's one of the easier lessons, I think, that we're going to do. So here's your homework. Now again, we have no idea what the snow is going to do. So if we don't have school tomorrow, obviously it's not due tomorrow. But if we do have school tomorrow, then it's going to be due. Don't say, I thought we were going to have snow, Mr. Hamrick, and I didn't do the homework. Well, it's still going to be late. All right, so get it done tonight. You don't want to spend your snow day trying to get homework done anyway. And I'm sure nobody's going to actually spend their snow day doing their homework. Maybe late at night before you go to bed or in the morning when you come to school. Well, it was yesterday, so it wasn't news to you. It was on the lesson plans, and I gave you the lesson plans for the week. So, all right, so there's your homework right there, okay? 224, 225, 1 to 18, section 5.3. It's not an A or a B. It's just section 5.3, 1 to 18. I did. All right, so there you go. That's your homework. Get it done. Again, if for some, believe me, I'm wanting to get off school just as much as you guys are. All right, so I hope we don't have school tomorrow as well. But if we do, I'll be here. I expect you to be here, and I expect to have your homework finished, ready to go. All right.